Today we are discussed about BCS theory. What is a BCS theory? BCS theory means it is a theory which explains a superconducting properties of the materials, which is innovated by John Bardeen, Leon Cooper and John Robert Schrieffer in the year of 1957. And before going that, we will discuss about what is superconductors. The superconducting materials is a very most exciting phenomena in physics, especially material science. The superconducting materials discovered by H.K. Once in the year of 1905, which is the first innovation of superconductor. But this BCS theory is innovated in the year of 1957. Almost 52 years, after 52 years, a new revolutions discovered by this BCS, these three scientists, John Bardeen, Leon Cooper and John Robert Schrieffer in the year of 1959. Right. What is superconducting materials or superconductivity? Some materials, the electrical properties is suddenly change, which means the resistance is suddenly fall when the material is subjected to zero temperature, at very low temperature. Now the material exhibit the resistance is zero. First, the superconducting materials examined by the material is mercury. When the material subjected to external temperature, the temperature below 4.2 Kelvin, it exhibit superconducting properties, which means it suddenly drop the electrical resistance. So resistance 0 means the conductivity is very high. That's why this material is called as superconducting materials. After that, the more number they are examined, the more materials they are examined. Like at very low temperature, the material indium, the critical temperature is 3.47. Indium 3.47. And the tin material Sn, which exhibit 3.72. Then the mercury, already you know that 4.15, that is the exact value of critical temperatures. So these all the materials which exhibit the enormous power of superconducting properties. Now we are coming to BCS theory. What is the BCS theory? Already discussed. Here the main core of this BCS theory is electron-electron interactions. Electron-electron interactions. Already we know that the electrons are always repel to each others. The electrons are always repel to each others. Here, based on Cooper pair, the electrons attract. Electron attracts. This electron pair is called as Cooper pair. The electron combines, which is called Cooper pair. Right. Here, the important features of this BCS theory is electrons forms a pair. This pair is called as Cooper pair, which means these electrons propagate through the lattice. The electrons propagate through the lattice. Here, the propagation of the Cooper pair without resistance because of the electron move the resonance with the phonons, which means the electron flow without any resistance, which means the electrons flow, which is the superconducting properties. Already know the conducting property, electron flow of electrons, conducting properties. Here in conducting materials you have a small amount of resistance, but here there is no resistance. Resistance is almost zero. Almost zero means the flow of electron is without no any barrier, the electron from one end to other end. Working of this BCS theory, already we discussed the electron interactions, electron phonon interactions, Here the formation of Cooper pair means nothing but the electron pair, which is called Cooper pair. Here the two electrons propagate along a lattice. This is the lattice. The two electrons propagate through a lattice. How it interact with the lattice phonons? The phonon gets, this is the positive charge. Here the electrons experience attract towards this positive charge. Both electrons attract towards the positive charge. So electron towards the positive ions. Now when the electron gets very close to each other in the region between the ions, here the electron towards the positive charge. Now already we know that the same charges with ripple to each other. Here the electron towards the positive charge, and it is towards move. Here also move the electron. Now the electron and electron close to each other. Electron close to each other means now the electrons are repulsion together. This is due to the Coulomb force. Already you know that if the Coulomb force act on two electrons means repel to each other. The Lorentz force means attract to each other, right? Here the Coulomb force acting on a body, that is two electrons. Now the electrons are repelled together. Then the electron move towards this directions. This electron move towards this. Now the electrons attract to the positive charge. Again the electron attract to the positive charge. It comes to very closer. Then the electron move towards the lattice point. Now electrons repel to each other. Now the electron move without any resistance through a lattice. Now the equilibrium conditions, the balance between attraction and repulsion, which makes two electrons combine to form Cooper pair. This is called Cooper pair. Electrons form Cooper pair. This collection of Cooper pair is a bulk samples which contains and to form the superconducting states, which means there is no resistance in between this lattice point. So electron can move easily towards the lattice points. Here we can explain on the based on zero resistivity which exhibit superconductors. Already we know that. Now consider one electrons of a Cooper pair to propagate through a lattice. Means how it propagate means, let us consider. This is one electron. Then you know that this lattice point, another one lattice point is here like this. So here this one is lattice points, and between the two lattice points the Coulomb attraction between the electron and ion which deform the lattice, which is propagate along the electrons, along the electrons. Now the propagating wave associated with these were propagated waves associated with the phonon transmission, which makes electron phonon resonance, electrons phonons resonance. Then the electron along the pair of the lattice which move without any resistance. Here electron phonon interaction. So electron phonon interactions occurs at the resonance conditions. The electrons move without any resistance. Based on this BCS theory, some of the predictions are found by this Bardeen, Cooper and Schrieffer. Based on this theory, they can found the isotope effect and the variation of critical magnetic field with the temperature. One is isotope effect. Second one is with the existence of energy band gap between ground state and first excited state. Based on this BCS theory, they can found energy gap between ground state and first excited state. According to BCS theory, the temperature T equal to 0, then the energy gap Eg is equal to 3.54 Kelvin Tc. Next one is, and based on BCS theory, the quantization of magnetic flux they can find. Quantization of magnetic flux also they can found, that is pi is equal to n pi 0 is equal to n h divided by 2 e. The value of the pi 0 is 2.068 into 10 power minus 15. So these are the BCS theory, that is John Bardeen, Leon Cooper and John Robert Schrieffer theory.